Okay. All right. Well, good afternoon, everyone. It is 1 o'clock Eastern. Want to go ahead and get us kicked off here. So thank you so much for your attendance and participation in today's webinar. This is on the 2025 report card for America's infrastructure, drinking water and wastewater chapters. My name is Josh Shoemaker. I'm Director of Policy Research and Industry Relations at the American Society of Civil Engineers. And today's December 11th. I'm just reading off my slide at this point. Today's December 11th. So again, appreciate your attendance and interest in today's topic. Advance our slide here. Okay, to give you all a quick overview of today's agenda, we will have an overview of the ASCE report card, our latest report, which came out in March of 2025. We will also go through different projects and case studies from our panelists today. The panelists will hang around for a discussion and we'll have some questions. This is where we'll pick up on audience questions as well as a few prepared ones, and then we'll close out the session. So to introduce our speakers today, first up is Samir Mathur, who is Senior Vice President and Water Reclamation Practice Leader at CDM Smith. We also have Lita Lavin, who's Manager of Design Plants at Northeast Ohio Regional Sewer District. We have Dr. Sunil Sinha, Professor and Director of Virginia Tech's Sustainable Water Infrastructure Management Institute. And then our moderator today is Celine Heyer, who is Senior Vice President at Arcadis. So with that, I will turn it over to Celine to give us an overview of the report card. Celine.
Thanks, Josh. And you forgot, I'm actually a member of the Committee on America's Infrastructure, more importantly, and have been working on the 21 and the 25 report cards. So thanks, everybody. So a couple of housekeeping items today. The webinar is being recorded. The recording and slides will be made available to you after this is completed. You can give your input via typed questions, and I'll be kind of like monitoring the questions for when we get to the end for the Q&A. You can send any technical issues or questions through the chat function, and hopefully Josh will be able to make any adjustments if you're not hearing us or seeing us. Okay, so today I'll be speaking about the overall infrastructure report card process and findings, and then I'm going to take a deep dive into the drinking water and wastewater report cards and really get into those findings from 2025. So you might ask, why is infrastructure important? And hopefully everyone on the call, we have a lot of engineers, would understand this, but it's really the foundation on which our economy, our global competitiveness, and our quality of life depend. A lot of times it's out of sight or out of mind, like those underground pipelines. But when there's deficiencies, we all feel it. It impacts our daily life. Those of us that drive, bad roads, that's always a headache. We like to get water from our sinks when we're thirsty, and we need electricity to power our homes. So ASCE is the nation's oldest engineering society. We have about 160,000 civil engineers. We serve as the stewards for infrastructure in the U.S. and around the globe, and we are a leading advocate for infrastructure. This report card that I'm going to dive into, it's like a school grading system. Many of you have seen it before. So it grades everything A through F, and we have 18 categories of infrastructure, which is here on the next slide. So here's a look at those 18 categories and the associated grades for 2025. Exciting, for the first time ever, the cumulative GPA is a C, and this is the highest it's ever been before. Also, for the first time since 1998, no category received a D- grade. So this is really indicating we've made progress around the grades in some of the infrastructure areas. In some cases, the grades increased or stayed flat. When I'm talking about water and wastewater, those remain flat. But generally, we had increased or sustained grades in 16 of 18 categories. So that was really exciting. So since the ASCE last report card 4 years ago, I think it's really important here to understand that the grades demonstrate the investment in infrastructure and that it has made a difference. So, the landmark federal infrastructure legislation, such as the 2021 Infrastructure and Investment Jobs Act, or the IIJA, that initiated thousands of critical projects across the country, 1.2 trillion in investment over 5 years, and more than 550 billion invested in new programs. And then we also had the Inflation Reduction Act in 2022, the IRA, and that was the largest climate investment in the US history and has helped facilitate the nation's transition to renewable energy sources. Go to the next slide. So some key trends that we have noted throughout all the infrastructure categories, and certainly applicable to drinking water and wastewater, is that there are extreme weather events that are stressing already aging infrastructure. Here in Florida, I had an odd Sunday where it rained 6 inches, which is quite interesting and doesn't happen too often. There's also a need for sustained investment to support the construction of key projects. So just because we've had some money that can go for design, we need to have that sustained investment, and we need to make sure that the new administration and Congress understands that need for the sustained investment. And then finally, we need to have reliable and available data on performance indicators. And when I talk to you about the grades and how we put them together, one of the big challenges we have is that there is no place that we can really go and get information on the national water and wastewater infrastructure. So let's move on to some of the details of how the report card is actually made. So the report card is prepared by the ASCE Committee on America's Infrastructure. As I mentioned, I've been part of those drinking water and wastewater report cards for the last 2 cycles. We currently have 52 engineers and infrastructure professionals from around the country that have decades of experience across the 18 various infrastructure categories. So with ASCE staff, the committee evaluates relevant data and reports where we can get data. And we look for things from government agencies, the private sector, nonprofits, other organizations. And us as technical experts, we discuss with each other to really get the best wide view of the nation's infrastructure and try to fill in some of those gaps where data is lacking. Again, there is no centralized database. And one of the challenges you may have seen, we do state report cards as well, but we can't just take the state report cards and average them together because they're done at different times. Some states don't have any yet. And until recently, they weren't really using kind of the same scoring rubric as the national report card. So it makes it challenging to assign the grades. But we do try to be comprehensive. So we evaluate 8 various categories to assign an overall grade. And these categories really touch on overall performance of the infrastructure. So we get a realistic picture. So let's start off with a detailed review of the drinking water report card. So the 2025 grades remain the same from 2021, as I mentioned, at a C-. Overall, our team really didn't find any significant data or trends to change the grade to make it higher or lower. In terms of capacity and construction, the grade was flat there. For capacity, there are a lot of public water systems in the US. They have ability to serve most of the communities, but there are pockets of population growth in certain areas and also lack of water supply in the right areas that remain challenges to get that capacity. The condition of the water systems generally also remain the same. We're seeing continuing challenges for being able to replace enough pipelines at the end of life with current funding levels. However, there were some slight improvements in water main break rates. If you look at the Utah State report, that really detail that we're starting to get the poor performing materials out of our systems, such as asbestos cement and cast iron, and replacing those with ductile iron and PVC, which have some extended useful life. The poor condition of pipes, unfortunately, also leads to things like revenue loss for utilities, when leaks and breaks occurred. And, unfortunately, we're seeing continued large transmission main breaks. One of the systems that I work with was in the paper last week in Georgia, where they had a large transmission main break and it closed down schools and really caused public disruption. So unfortunately, that's still happening. So moving on to funding. Funding also pretty much remained flat. User rates have increased over the last 10 years. However, the majority of utilities that were surveyed by AWWA still felt like they didn't have enough funding to cover the full cost of service, and that would be both the capital and the operations and maintenance needs. There was funding that was infused for the federal low interest loans for water capital projects. That's the Drinking Water State Revolving Loan Funds. But those funding levels really have not significantly increased for the drinking water sector. And we have a practice where a lot of that money gets earmarked by Congress for specific project grants, and then that takes money away from the states that can get those loan funds approved. Under future needs, the needs have increased, not surprisingly, as things have been deferred, so that reduced the score in this category. According to EPA, needs have increased about 30%, with a total need of $625 billion over the next 20 years to meet a state of good repair, and this is up from $473 billion previously projected. The ASCE also has performed an evaluation as part of the Bridging the Gap report, which showed we need increased funding up to over $2 trillion by 2023 to be able to pay for infrastructure replacements and new needs. Under operations and maintenance, that also remained flat. While we saw some general maintenance practice improvements to becoming more proactive versus reactive, the planned maintenance ratio, according to AWWA benchmarking, showed that. However, workforce still remains a challenge. EPA reports about a third of the operators are eligible for retirement in the next 10 years, and the median age of workers is getting up there at 48 years. So attracting new workers to our industry is really a key issue. Public safety also remained flat. Most utilities have evaluated their risks, but cyber attack risks are a current challenge. EPA reports that many of the systems that they've inspected are violating requirements around cybersecurity. Water quality issues continue to be a challenge due to lead service lines, and that's a hot topic of the day. Having to replace over 9.2 million lines in the next 10 years is very significant. And obviously, we've all heard about PFAS and emerging contaminants that threaten water quality compliance and could impact 45% of the water supply, according to the USGS. Resilience challenges have increased, which reduces the score in this category. Climate change and extreme weather, including hurricanes, floods, freezing, and droughts, continue to pose threats on infrastructure where pipes are breaking, pumps failing, and water quality being impacted. Only 72% of utilities have completed their required risk and resilience plans, including updating emergency response plans, even though these were all due in 2021. Innovation continues to advance, increasing the grade in this category. There's greater use of digital technologies and data-driven decision-making, leveraging things like machine learning, AI, performance dashboards. AWWA shows that 43% of utilities plan to install new IT systems, and 46% plan to install digital meter reading, which provides greater access to data for decision-making. Moving on to the wastewater report card. Again, the 2025 grades remained the same as the 2021 grade at a D minus. At a D plus. Overall, the team did not find any significant data or trends to change the grade. In terms of condition and capacity, the grades remain flat. For capacity, the number of wastewater systems has increased to serve urban areas. However, some systems still remain stressed for capacity during wet weather events or those growth areas. For condition, advanced treatment requirements in some areas are causing performance condition failures for equipment, where new technologies need to be installed to meet higher water quality needs. And the number of sewer main failures has slightly increased according to AWWA benchmarking, indicating we still are in a cycle of aging infrastructure. Operations and maintenance remain flat, where most utilities have digital tools to address their operations and maintenance needs, but many have not been able to upgrade these systems or really figure out how to best manage and leverage the data to help them with decision making. Funding also remained flat. While average sewer bills have almost doubled, it's still not keeping up with the cost for existing capital and O&M needs. And further increases sometimes make it unaffordable for disadvantaged areas. Funding availability was also flat. Some additional potential allocations were made by the IIJA for the Clean Water SRF, but most of the dollars were really allocated to address new needs for emerging contaminants or allocated to disadvantaged communities and were not available for the wider, larger to medium utilities. Future needs are increasing, which decreased the score in this category. The ASCE Bridging the Gap showed an overall gap of $91 billion for the water sector annually, with $69 billion of that related to wastewater and stormwater, with a projected growth rate of $690 billion gap by 2024. So lots of needs there. AWWA also reported that utilities are generally trying to invest about 1.5% to 2% for replacing infrastructure. This equals like somewhere around a 50 to 100 year lifespan, but this is probably too low, right? And we also need to deal with the advanced treatment processes for considering future emerging contaminants. Public safety remained consistent with a slight drop reported by EPA in the number of combined sewer systems that have historically had wet weather discharge issues. But the number of sanitary sewer overflows has been pretty consistent since about 2018. Resilience and innovation also remained flat. Wastewater vulnerabilities generally vary by location. However, in 2022, the Precip Act was actually approved to allow NOAA to update maximum precipitation estimates, which support advanced planning. If you don't know how much precipitation is going to happen, it's very difficult to have a good plan. Envision framework has been around for about 10 years, and that focuses on sustainability, resilient, and equitable solutions, but it's really not been widely adopted by the wastewater utilities. So there are organizations, however, like WEF and others that are providing materials to the sector to help with best practices on sustainability, resilience, and innovation to help promote more adoption for this category. And finally, wrapping it all up, yes, there are challenges, but what can we actually do? And you're going to hear about a lot of these things in our presentations today. What can we do to raise the grades? The first one is near and dear to my heart, and that is encourage asset management, because that's really going to help us identify the high-risk things where we can prioritize our limited funding. We need to make sure rates cover the full cover the full cost of service. You know, where people can pay, they need to be paying, and have affordability programs for where those are challenged and need help. Maintain the investments that were done by the IIJA and continue to make sure that that we're investing in our infrastructure. Factor in resilience towards climate change and severe weather needs during planning. So don't plan in a vacuum. Make sure that you understand what the future looks like. Expand collaboration to be able to deal with things like PFAS or other biological components. Where feasible, merge smaller utilities. There are a lot of utilities in the U.S., and some consolidation could really help with having a bigger rate base to meet the future challenges. And finally, we really need to get that workforce of the future and have people be excited about getting in the drinking water and wastewater industry. And with that, I'm going to move us on to our first case study. And Samir, go ahead and take it away.
Thanks, Celine. Good afternoon, everybody. So, Josh, if we move on to the next slide, my agenda for today, I'm going to touch upon a lot of things Celine talked about in the categories that formed this report card. So, as an engineering consultant, I'm going to talk about some of the drinking water and the wastewater, like market trends that we're seeing and where we see the market going. And then I'm going to dive into some specific processes in wastewater where we've been able to use some of these innovative processes and technologies to provide benefits to a specific wastewater plant, which will form my case study. And again, I'll wrap it up again and touch upon some of the criteria that were identified in the report card for drinking water and wastewater. So, Josh, next slide. So let's look at the drinking water market trends. So like Celine mentioned, lead service line replacement is a big trend. We're winning a lot of big jobs. That's transitioning from the push from initial inventories and understanding where the problem is to actually going to replacement and doing corrosion control studies and things like that. Aging infrastructure is a huge need. Significant needs to replace water treatment plant processes across the country, both on the pipeline, on the treatment plant side. So that's a huge trend we're seeing. And we talked about the climate change impacts. We've seen like changes in treatment at a water treatment plant needed to address changes to source water quality. So any floods, fires, drought could cause a change in the source water quality that would lead to a project that requires changes to the way you do treatment now at the water treatment plant. On the wastewater market side, of course, on the drinking water, we've got the PFAS that Celine talked about, but on the wastewater side, we're starting to see PFAS in wastewater and biosolids and states. So one thing that's different from on the drinking water side versus the wastewater side, on the drinking water side, the EPA's got rules and regulations to drive some of the requirements for PFAS treatment. But on the wastewater side, we're seeing more of that happening on the state side. So each state is trying to establish their own regulations and establish how they want monitoring to go on. So that's kind of driving, especially on the biosolid side, is where we're seeing all that happen. Treatment optimization and efficiency is a big thing. Given the fact that the funds are limited, um, and there's a lot of aging structure, there's this idea of doing more with less. How can we squeeze out more capacity in a wastewater plant by reducing the amount of infrastructure needs? And that's exactly what my case study is about. I'm going to talk about some of that. Digital tools are coming up big. You see digital twins, assist with O&Ms, tools for that, etc. On the reuse side, we're seeing a rapid evolution of direct potable reuse regulations in several states that are listed there. And we're also seeing growth in what you would consider non-traditional states, like Ohio and Iowa, like Midwest, Kansas, Illinois, where we're getting projects on reuse, where you might think mostly, reuse was more in California or Texas, but we're seeing it a lot in the Midwest as well. So a lot of people are thinking about that. So moving on, Josh. Okay, so now let's jump over to this idea of more or less. I'm doing more with less. The process intensification in wastewater treatment. So the idea here is to use innovative technologies to make treatment more efficient, more compact, and more cost effective. And basically with the idea of lowering the energy use, using less chemical resilience, get higher quality, higher capacity, and also with that goal of increased resource recovery. And we've got several technologies, aerobic granular sludge, which forms these granules. You see that picture there with the person holding these granules in their hand. So these are larger granules that help process work better and getting more out of the process with increasing settleability in a process. Densification, which I'll talk about in a second in detail, does the same thing. It increases the capacity by helping you settle better in a wastewater treatment plant, therefore increasing the capacity in an activated sludge system. You've got membrane aerated bioreactors, which include your nitrification capacity in a wastewater treatment plant by putting in these membrane cassettes in certain zones, etc. So we've got a lot of these methods now, and I'm not going to get into detail on all of these technologies, but I will talk about the application of one such technology. And Josh, if we move on to the next slide, I'll talk about my case study, which is for the city of Wichita, Kansas. It's a project where it's ongoing right now for us at the wastewater plant number 2, and it's the biological nutrient removal improvements project. So the permitted capacity of this plant is 54 mgd. The current average flow is about 30 mgd, and the flow discharges, the wastewater effluent discharges to the lower Arkansas River in Wichita. So moving on, Josh. So here's what the project's about. It is, the existing project, the existing treatment plant has trickling filters, and it's a two-stage process. The first stage is trickling filters. The second stage is nitrifying activated sludge. These facilities for the second stage were built in the late 80s. The trickling filters are from way before that. The existing aeration basins are not designed for BOD removal of BNR, and the plant received BNR permit limits. So we now had to design a system to remove phosphorus and nitrogen, which the plant was not designed for. Also, I want to point out that there are 3 separate systems. So you can see on the graphic there, there's aeration basins 1 and 2, there's 3 and 4, and 5 and 6 to the top right corner. So they're basically 3 separate plants. And I'm bringing that up because it'll play into how we did some of the piloting work here. Also, as part of these improvements, we're going to abandon the trickling filters. So the goal here was to improve the process, meet some new permit limits, and abandon some old aging infrastructure at the plant. So next slide. So to do this, the first step was to use this innovative technology, which is called indents. And it basically uses these things called hydrocyclones to essentially intensify the process. You can granulate some of the sludge, and you can settle better. And by settling better, you can increase what's called the mixed liquor capacity of the aeration tank, and therefore increase the performance. So that's the idea behind this process. Now, we installed this pilot in only trains 5 and 6. Note I mentioned there were 6 trains in this plant, but we ran this pilot only on a couple of trains. And you can see from the picture, the setup was pretty simple. We installed these skids on top of an existing tank. That's a tank where they distribute, that provides flow distribution. It was a 4-cyclone indent skid, and there was a feed pump and a return pipe, and you can see a lot of temporary piping. So we started off with 1 train, but then we expanded it in 2 trains in 2021. So let's move on to the next one. So again, as we're doing these pilots, our goal here is to figure out if we're really getting benefit out of the pilot, right? And the unique nature of this facility allowed us to do the side-by-side comparison. So we had, like I mentioned, the 6 basins. So first we started off with just piloting in basin number 6. And we could see SVI 30 is a measure of settleability, how fast the sludge settles. And you can see in that orange line that for that basin number 6, we always got stable readings. The lower the SVI, meaning the better the settleability, which is a good thing. It's better for the process. That shows that we've got a stable process. And you can see in the other basins, not only were the SVIs higher, they were also a little more inconsistent. So that's one thing that came out. Thumbs up to that. We showed that the process would do its job and it would help. Moving on to the next slide. Okay, now things really changed. So I live in Texas, and several of you may remember this winter storm Uri in February 2021. I live in Dallas. We lost power in my house for over like 2 to 3 days. We had no power. And of course, it really hit big time in Texas and in the Midwest. So what you see is our pictures from Wichita here, from that wastewater plant. And our plant operator there laughingly calls what you see on the right picture poopsicles, because everything literally froze. And the air and the bubbling that was coming out was freezing some of the water on top of these basins. So you can see, call these poopsicles because that's really what was happening. It was freezing downright. So if you go to the next slide, what we observed as we were going through this pilot, that the basin that had these hydrocyclones, this indents process, kept chugging along. You can see the orange line down there. It met its nitrification all the time. Meanwhile, the other 5 basins completely lost their nitrification. They had a process upset because all the bugs died. and the process was not stable. So the city spent substantial funds and over 400 hours reseeding the remaining 5 basins to bring the facility back in compliance. But basin number 6 had no bulking and it met all its permit requirements. So if you go on to the next slide, Josh. So with that said, we knew that this process was effective and stable, and we wanted to incorporate it into our full-scale design. So again, the design goals here now would expand the plant capacity. So there was an expansion involved to get the plant to that 30 mgd flow, meet new BNR permit limits, abandon the trickling filters like I mentioned before, modify the system to make it more operator friendly to what we're calling a one slut system, meaning bring all the RAS and the WAS to one structure upstream of the BNR structure. We should see that green BNR structure. That's a new structure we were constructing, or we wanted to construct, and then distribute the flow from there, meaning there were not going to be these separate plants anymore like they had in basins 1, 2, 3, 4, and 5, 6, but bring it all together in one common place, making it thus, because if you had this different basins, the plant operators had to constantly run out, and basically they were running 3 different plants. Now we're trying them to run one plant and bring it all the RAS back together in one place. And through this process, incorporate a full-scale hydrocyclone facility in the upgraded plant. Bring it all together and incorporate this innovative technology. So if we move on to the next slide. So again, as we're incorporating this new technology, we had to think through a lot of design steps, like where to locate it in terms of process, how many hydrocyclones to bring in, location of the facility, how do we pump it, how do we return the underflow, what do we do the RAS, WAS, do we put a building or a structure to house these, how do we operate them, and if they're not working for some reason, can we bypass them, and what will we do about that? So all these were considerations we had to go through just for that aspect of the design. Keep going. Next slide. So I'm just cutting to like the design is done. Here are some of the 3D renderings of the design. That's the new, on the bottom left, you can see the new BNR basin. It's a huge basin. On the middle picture there, on the left side, you see the hydrocyclone building. We eventually decided to cover the facility with the building being Wichita, and it does freeze. A bunch of pump stations around the structure. And then on the bottom right, you can see the hydrocyclones, the 5 skids that be installed to incorporate into the design here. So moving on to the next slide. Here, the project is in construction, so I just wanted to share with you some of the construction pictures. So on the top left there, you see some of the clarifiers work, a major rehabilitation of some of the existing processes. We're covering the clarifiers. We're providing a lot of odor control on this job. Bottom left, you can see the clarifier being rehabbed and the BNR structure being built in the middle of the facility. And you can see some of the existing basins on the top right of that picture with the clarifiers there. The trickling filters are still functioning, but will be abandoned eventually. Middle picture shows the BNR structure walls coming up. And the bottom picture there shows the clarifier rehab. And on the top right, you can see the starts of the BNR of the hydrocyclone facility with the tank and the pumps that we're constructing. And on the bottom right, you can see some of the rehab going on in one of the existing pump stations. So next slide, Josh, and I'm trying to bring it all together here. So what I try to present here is incorporation of how we incorporate several of the criteria from the ASCE's report. So this project looked at capacity and condition. I've talked about how we increase the plant capacity, and there was a lot of rehab of existing infrastructure. The funding of this project was through WIFIA. So we did use public funding to fund the project. Operation and maintenance, we providing a high level of automation and data management through this project. Future needs. The plant meets future population growth and future nutrient limits, and also gets ready for any future reuse and any other future solids management. We're also looking at renewable natural gas and trying to put in a program that can sell that that gas back to a pipeline, thus giving more revenue to the city. There's public safety and resiliency aspects. The new infrastructure provides increased safety and resiliency. And you could see from my pictures there how we've got these processes now that are more stable, and we're ready for that next winter storm should it arrive. And of course, innovation. We talked about the process intensification using hydrocyclones, and how we've incorporated such a technology into a mainstream upgrade of a wastewater treatment plant. So with that, I'm going to hand it over to Lita to talk about her slides and on the funding issues.
Thanks, Samir. Just give me a moment to get my slides. All right. Can everyone see
Yes.
my screen? Awesome. All right. So as Samir mentioned, I'm Lita Lavin. I'm a manager of design for our treatment plants at the Northeast Ohio Regional Sewer District. I'm also, similar to Celine, also a member of the Committee for American Infrastructure with ASCE. And today I'd like to share a story of how the sewer district as a regional utility has been supporting local communities addressing their local infrastructure issues. Let me make sure these slides can advance. All right. So just to give you some background on the Northeast Ohio Regional Sewer District, we are located in the greater Cleveland area. We provide sanitary sewer services to 62 member communities and the city of Cleveland, as well as stormwater services to 56 member communities. We service around 1 million customers and treat 90 billion gallons of wastewater each year. On a daily basis, it's around 200 million gallons each day at our 3 wastewater treatment plants. We have 344 miles of those large interceptor sewers, and then we are responsible for 485 miles of regional stormwater system. We also conduct a lot of water quality monitoring across our service areas in our receiving waters. And we also conduct Lake Erie Beach monitoring and maintenance after CSO overflows to maintain those areas. I want to focus a little bit on our wet weather program. So in addition to the day-to-day collection and treatment of wastewater, we do have specialized wet weather programs at the Northeast Ohio Regional Sewer District. Our Project Clean Lake is our CSO long-term control plan, which was signed into effect in 2011. It's a $3 billion program. We're about a little over halfway through that program, and that is funded through our wastewater rates, and it's based on water consumption. We also have a separate program, our stormwater management program, which collects around $50 million in revenue, which is a separate fee on the utility bill. And that program specifically is addressing regional flooding, erosion, and water quality issues. And that is a separate fee based on impervious surfaces. So as I mentioned, the sewer district is responsible for those large interceptor sewers that come to our treatment plants. So we have those obligations as well as implementing our CSO long-term control plan. But as I mentioned, we also have 63 member communities. And those communities have over 3,000 miles of locally owned sewers. And those communities have issues such as sanitary sewer overflows, aging infrastructure, which lead to a lot of infiltration and inflow, also known as I&I. A lot of times there's these illicit connections to these sewers causing water quality issues. And then in some areas of our service area where sewers have not been extended, we do have septic tanks, which a lot of those in our service area are old and have failed. So what I would like to kind of hone in on today is more on the local side of all these local responsibilities of our member communities, because they're a big issue. You know, as Celine has mentioned, and when she talked a little bit about the funding gap, it's really difficult when there's a significant need to address aging infrastructure, building new sewers, when you don't have a funding source. One other thing I wanted to highlight with our local sewers is something kind of unique to Northeast Ohio, our common trench sewer manhole and trench configurations. This was probably considered innovative at the time when they were constructed 75 plus years ago. And they're very problematic today when you have the storm sewer constructed right on top of the sanitary sewer, sometimes separated by an invert plate. When those invert plates or those sewers age, the water seeps into the lower sanitary sewer and causes a host of issues such as basement backups and sanitary sewer overflows. So this is a significant issue in a lot of our local communities where they're seeing a lot of these issues causing these types of problems. So I want to talk a little bit about our local sewer system evaluation studies that we completed back in 2022. And kind of taking a step back, when we were implementing our CSO long-term control plan, we were doing some advanced facilities planning to lay out the long-term program, how we were going to execute our consent decree. And we did an integrated planning evaluation as a part of that study. And what we came to realize is those local, while we're addressing our CSO issue from the district's perspective, there are a lot of these local issues, as I mentioned previously. So with some forward thinking of our sewer district leadership and with the support of our board of trustees, we began these local sewer system evaluation studies, which are planning level studies. These are not the traditional SSESs that we did years ago, going street by street and doing all those condition assessments. It's strategic evaluation of community reported and model projected problems. This was a $40 million investment across the different service areas shown on the slide here. And again, this was kind of taking the reported problems from our member communities and then giving them tools such as doing strategic field work, such as dye testing, a lot of flow monitoring across the study area to kind of assess how wet weather was impacting these local sewers, and then building a model to evaluate where these problems manifest and confirming where the reported problems were, and then developing where they may occur in the future, some of these projected problems. And then we developed community reports to document all the findings and the recommendations. And Celine had mentioned, asset management is really important. One of the tools that we also provided the local communities was access to geographic information systems, or GIS. So we were able to take a lot of information and put this information, rather than having to search through a report, into GIS. So being able to digitize all the sewers, their local sewers in GIS, linking the drawings that they had. So with the click of a button, they were able to get all this information to readily address these issues. So the local sewer system evaluation studies develop solutions into 3 categories. The first category is known problems. Again, these were mainly the community reported problems, which were in most cases basement backups. Known structural SSOs that were activating. The level of service that we were evaluating for these studies were the 5 and 10-year rainfall event. And then developing solutions in the short term. Tier 2 was excessive infiltration and inflow. So maybe areas that didn't have problems, but there were significant amounts of flow. Your eyes are not deceiving you. When you see the number of 50,000 gallons per acre per day, we were seeing much higher results in particular areas of these study areas. And as I mentioned, like these common trench configurations, there's potential for those cross-flow pollution to provide or cause some issues to our receiving waters, polluting those streams and our lake. So again, prioritizing those into midterm solutions. And then again, as I mentioned, model predicted. So these may not be reported problems today, but something for communities to kind of keep in the back of their mind. Due to aging infrastructure, they may see these basement backups in the future based on these modeling tools. And again, modeling was something that is not typically used by local communities. And so again, this was again bringing some potential solutions to them to use, and also making sure. I think the big thing with models as a tool for innovation is making sure they're not taking a problem that exists in one place and moving it somewhere else. And so these studies were able to kind of help guide the communities on how to implement what the solutions are, where they are, and how to implement them. So at the bottom of the slide, as you can see, district-wide, the studies came out with around $3.5 billion in additional work for the local communities to implement. So this is great. You know, we've got a plan for these communities of how to address these issues. But the big question is, how do you pay for these solutions? And that's, again, forward thinking of our leadership, and with support of our board of trustees, we developed what's called the Member Community Infrastructure Program, which is a funding source. It's a competitive grant on an annual basis that provides funding to our local communities to improve infrastructure. When we started out the program, it was around $5 million, and now we are around $15 million annually to support aging infrastructure issues. In total, the program has invested to date $123 million towards 159 projects. And as I mentioned, this is a competitive grant program. There is a match requirement, so this is leveraged an additional $110 million in local investment. And then this slide here kind of shows the cumulative benefits of remediating basement backups, addressing SSOs. Regionalization is a big piece by being able to take away some of those smaller plants and have them come to our facilities where we can efficiently treat that water. Removing septic tanks, and then rehabilitating or constructing new sewers to address local infrastructure issues. Now, another funding source, which was previously mentioned before, IIJA. Since we had that program was launched right around when we completed the local sewer system evaluation study. So we were able to leverage the results from that study to help support our local communities obtain some potential grant funding. Ohio received an additional $50 to $70 million in supplemental principal forgiveness loan, which is effectively a grant. And so we wanted to help support communities that were eligible for that funding, obtain that funding. And so we provided annual support to nominate these projects. We have used the Water Pollution Control Loan Fund here in Ohio to fund much of our CSO long-term control plan. That program is not as familiar with some of our local communities, so we offer to assist them to try and get that funding and any other technical assistance to help them manage getting that funding. And so since 2023, we've helped 9 of our member communities apply for $35 million in funding for Infrastructure Investment and Jobs Act funding. And right now, this includes some of the draft 2026 program management plan results, which actually just came out 2 days ago. We have identified $16 million in these grants that have either been received or eligible by 5 member communities. And then those communities that weren't offered the principal forgiveness were offered traditional low interest loans. So kind of bringing it all together, when Samir was talking about innovation on using different technologies, which we were doing in these local sewer system evaluation studies. As I mentioned, it was using a lot of modeling to help support identifying problems and developing solutions. But really, the innovation, I think, here is just the forward thinking of trying to how do we solve problems, and developing funding in order to address those problems. And so I kind of attribute that, all the innovation, investment, and resilience is really good planning, putting up that planning up front and developing and providing resources to address these issues. And so the local sewer system evaluation studies did modeling at a 5-year level of service to ensure resilience. They looked at a 10-year level of service. A lot of times when you're just trying to go from that increase that level of service just slightly, it doesn't add a lot of additional cost to your project. So making sure that you're looking, to make sure you have that additional resilience by assessing, the potential benefit of a higher level of control. Being able to guide the local communities how to address those solutions, and then also leveraging those results of those studies to obtain IIJA support and funding. And so that's the big story. I think, I wanted to kind of bring all together is, the forward thinking and out of the box, and collaboration with others is really a good way to get the job done. And so with that, I'm going to turn this over to Sunil to share his case study.
Great. Okay, so thanks, Lita. Let me share my screen. Okay, great. I think everyone can see my screen. Thanks a lot. Thanks everyone for this presentation and ASCE for organizing this. So what I'm going to talk is, you heard about from starting with the Celine talking about the whole data issue and the report card, the grade. Then Samir came and talked about the innovation, also aging infrastructure issues. And Lita talked about linking with collaboration and making an impact in the community. So I will focus on not just innovation. Of course, most of my talk is related with innovation, but it also related with how it can impact resilience, water security, asset management, and economic analysis. So title is here, as you can see here, artificial intelligence, and everyone talks artificial intelligence, but the key is the data. That what data we take into consideration and how we can analyze those to improve the national water efficiency from source to tap. So this is a project came, but before I go and talk specifically, this slide, what you are seeing here is, I will talk mainly public water supply, but what Lita mentioned, there is the wastewater, there is other domains of water. So it's very important to understand there are many other aspects of the water which can affect the water efficiency. So my talk is limited here, just public water supply from source to tap, but there are some effort going on. Even we have submitted some grant and all those to work in data center, as you know, is coming. That is affecting the water supply in the neighborhood because they need electricity, data centers, but they also need a lot of water for cooling, and that's the water they consider as the cheapest source of cooling these centers. Then water is also used for irrigation and other purposes. So to truly understand this, the whole water efficiency, we need to touch all domains. We need to collect data because there is the dependencies and interdependencies. But my talk today will be just focus on public water supply. So this project came to us in 2022. Before that, this is under Secure Act. I don't want you to read. Probably you will have access to the slides. So the key thing here is that this was built on many other projects we did. This is kind of a 20 years of work I'm going to present you in 15 minutes. So there was a pipe ID, water ID. These are all federal grants came from aging water infrastructure. EPA, the water ID was created as a knowledge base. Then Congress wanted to have a national database of water pipe in this country. 700 water utilities participated. Then in 2022, when we finished this pipe ID, then came under Secure Act how to develop this machine learning model which can be applied for not just large utility but utilities of all size across the country. So that is the key here in this which I'm going to present. So it's model and tools what has been developed should be applied to all communities of all sizes across the country. And this project is of course under Secure Act. So this is still ongoing. So result I'm going to show you is very preliminary. We still have to submit this report to the federal agencies, then it will go through the congressional approval before it can be made public. So this slide is very important. The source to tap. When we say source to tap, the data has been collected from what you are seeing, system 1, 2, 3, 4, and 5. So system 1 is we divided this as a system of systems problem because that's very important to understand the data. So system 1 is all the water quality and quantity, but also there is a surface water, groundwater, and then recharge and all those. So all those need to be taken into consideration. Then how water is moving before it is coming to the treatment plant, then coming to the distribution, which is 4. So you may have heard about water audit and all the. So there are many study has been done, but this is kind of a looking at all in the previous study, what kind of a data, and then bringing. But system 0 was added actually when we started this project. We only started with system 1, 2, 3, 4, and 5. But S0 is important because the context is very important where this utility or community is located. What is the scenario there? Is it a mountain area? What is the economic scenario? Is it a small, large? So that's very important in any modeling to understand the characteristics of that. That's why system 0 was added in there. Although the analysis is being done in 1, 2, 3, 4, and 5 to understand the whole water source to tap scenario, but data. So Celine brought this thing, the collecting the data and good quality data, because data is also comes in many shape and form. And what we are talking, so I can go on, but we have limited time here. Data is not one shot. It's also time dependent. Is it 100-year data we are collecting? Is it a 1-year average? Because it depends on what scenario analysis you want to do. So in the beginning, when this project started, the condition was from OMB that you have to pick one state east of Mississippi and one state west. So we did started with Georgia and California in 2022. But we couldn't do much in California because in Georgia, understanding, collecting all data, Georgia has 3,000. It's not like California, but it's still a lot of utilities. We couldn't get data from each and every cities and town. So how you extrapolate, you interpret. So there's a lot of issues there, right? I'm not saying these are perfect, but methodology, which I'm going to show you, will estimate in the right way. And this can get better and better. These are all machine learning algorithms. But still, lot of utilities participated within the state. Now we have many states coming. I have to update this slide actually. And then American Water became a big partner, let me tell you. American Water, why? Because American Water is not just one utility located in one state. There are many. And they also have military bases, this and that. Why it is important? Because characteristics. It's all about the data characteristics so that we can apply that. And then, of course, with Pipe ID, we got 700 water utilities, the data set, which we feel, and then federal agencies. But let me briefly tell you that data, when we get from like USGS, it's not the same resolution. USGS don't collect data at the utility scale. The utilities are more like a political boundary. Most of these are HUC, what they call hydrological units. But in each hydrological unit, there may be 10 utilities in there. So doing this all manipulation of this data, slicing, dicing, is a lot of manual work, I will tell you. So anyway, so collecting all this data, once you have, then you will ask me, okay, how this was done. So bottom-up approach we took is where we tried to select the utilities, small, medium, and large, all over US. also trying to understand the characteristics of these, whether they have surface water, groundwater, different kinds of situations. So bottom up was very rigorous study was done where we had to sign memorandum of understanding with these utilities so that data, because they were scared of sharing this detailed data because they don't wanted this data to go in public domain. So bottom up was very rich, all GIS, all their SCADA system, everything. So we got very good data from these 50, 60 utilities all across US to really understand. But that level of data we didn't get from other utilities, say 200, 300. That what we call is the middle out. That we created a cohort level analysis. This is like a very detailed, all GIS. We know the pipes, where it is located, what is the diameter of the pipeline, many meetings and all those to understand, because data is not black and white. Data has the physics behind it. So understanding all those is very important. And then we can apply now to the entire country. That's how it is. And I will show you the results. So that's kind of overall. So how whole thing is working is it is just like your chat GPT. When you go, you don't care about how models are trained, but chat GPT works in the same way. They search data from all over the world, but concept is very similar. So we have agents. So if you look at the system, of course, I'm not showing you your system zero, but system zero is the characteristics which is flowing through across all 1, 2, 3, 4, and 5. But all these are agents from the computer point of view. So machine learning is these are agents. So then you will say, okay, what is agent for the system one? Water quality and water quantity. But these agents are multiplying because you have groundwater, surface water. So agent is nothing but models, basically, right? But they are talking to each other so that error is not propagating. And that's where these agents supply to the foundational model, which is the middle one. What you are seeing is that takes the input from all, calculates the error and all those. But we do have check and balance. The QR, QP, what you are seeing here is how much water is being withdrawn by the utility, how much entering into the treatment plant, what's leaving treatment plant, how much is going to the distribution. Of course, the errors are there because the meters are not calibrated, those kind of a thing. But then at least we will know from where error is coming, how it is propagating, which we can fix in the future. So that's how this whole thing is built up. And then, of course, you have surrogate models. Surrogate models are basically nothing but just like you are asking question in chat GPT that can you tell me, or you write some sentence, can you correct this sentence? That's how it is done, right? So it is kind of a very similar concept we adopted to do this whole study. So if you look at the flow diagram, it's very simple, actually. The first, we definitely need any city and town to tell us how they are withdrawing the water, groundwater, surface water, how many treatment plant, how much miles of pipe they have. It is a surface water, groundwater, what kind of filtration. So we need some basic characteristics, like a flow chart. Once you have that flow chart from source to tap, by the way, then data. They don't need all the data in the world, right? They can start with very basic. Just like you go to a doctor, you don't need CAT scanning right away. So you can have a basic data set, then machines takes over. Then performance, and I will show you that. I mean, devils are always in detail. You can challenge me then how it is done. Yes, everything can be improved, but the whole structure has been set up in a very modular way, just like people do in medical and other industry. So that's why this effort is not just by one university and by few students or one professor. No, a lot of federal labs are involved. A lot of utilities is involved in developing all these models. So it's not just I will claim the model is developed just at Virginia Tech. So then performance analysis, then water efficiency and economic can be done. So, okay, so how it is done? These all models, basically system one, system zero, the data comes. So this is the foundational model. So we have three foundational model. One estimates the performance, then performance is tied with the efficiency, and then efficiency with the scenario analysis. These are very modular structure. What that means is that anything can be changed. Any agent can be plugged in. It can be deleted if we see. So all model right now is frozen. What that means is it's not learning mode. So now any utility we are feeding the data, it is predicting the result model is not learning. So it has been tested and trained, it has been frozen. Next year, we can come back, we can unfreeze it, and we can train. But it will not lose the memory, what it has learned. So just like a child, when it comes from school to college, the memory is not lost. It will keep learning. So that's kind of the structure is, but it's very modular. We can bring in any agent. So this is just showing you how this performance can be, but we are using the same like ASCE report card. We don't have F grade here, but highest is 4 to 5, which is A grade, then B, C, D, and E. F means like it has failed, that you go and replace it, right? So that's why we have used A, B, C, D. Then you can relate with the efficiency, how much water it is from source to tap. Again, the disclaimer here is I have put a disclaimer. We are still working. This has to go to the review process. But we have checked what USGS is reporting, what other is reporting. It's coming very close because our approach is bottom up. We are estimating from cities and town. USGS approach is from the top down. So they are claiming that the water withdrawal for public water supply is around 37 billion gallon. Our bottom up is estimating around 41. So we are within the margin of error. It's not like that, but anything can be improved. The key is the methodology right now. Then economic can be done. So what is this slide showing you is basically if you built a new any facility water, then that's the dotted green line. This is again hypothetical. We are not allowed to show any utility, but that dotted green line is that's what the utility should be providing the service to the customer. They should be charging that. But majority of the utility is dotted green, red line, what you are seeing here. So that is costing 5 times more, right? Because of the aging infrastructure, because of inefficiency, practices, many things. I will not blame everything on the leaky pipes or infrastructure. There are many things going on here. But they cannot bring to the green level, but at least to the dotted gray line, that is achievable. And that's scenario analysis. So this is all decision support. These are not decision making tools. So now it is up to the utility how they want to play with that. This is again showing you that the model has capability to produce for the entire country because this is a bottom up. So it can be, then it can be calibrated, it can be improved. So that's the whole game plan was right from the beginning, that how it can estimate. So don't look at right now and think that, oh, this state is losing more, this state is better. No, that's not a purpose here. The purpose here is to, we can slice and dice, we can show you in whatever way, as long as data is there. But this green one, what you are seeing in the right-hand side is the confidence. So the key, we are also telling how much confidence we have in this data, what we are producing, because that's the key. If a data is very limited from certain state, then you cannot tell that the confidence is 90%. There's no way. But in some state, in some utility, yes, we do have confidence 90%. But a lot of utilities, confidence is just 50%. That's like a guesswork, right? So that we have to keep in mind. So coming to the data, I can go on and on. We have to be careful here when we say about data. When I showed you one slide, average loss is 40% in this country. What that mean? Average 40 doesn't mean much. That's not an average because your data is not normal distributed. Just like a cast iron pipe, we have seen a cast iron pipe can go from 20 years to 200 years. So how can you take average that? And if you are replacing the pipe based on average, you are pulling pipe early, that pipe could have lived for another 20 years. So that those are the very important, and that's what I have written here. Design life is not performance life. You cannot use that a pipe is laid, then or any asset, it can go 100 years. No, it will not. A baby is born healthy doesn't mean that is going to live that 100-year life. So our whole model is based on data and knowledge because nobody can claim they have all data in the world. So you have to integrate data and knowledge. So all models are trained in that way to mimic that. We haven't done yet right now, but that is our aim is that, yes, model this and that, but why utility care about these models? They want that interface where they can put, just like you guys use ChatGPT, right? Everyone uses ChatGPT. You don't care server, you don't care about, you just want answer. You want reliable answer, you want trust and all those. So this we still have to do. So we are not done yet. So the benefit, I feel there is a big benefit in this because each utility cannot collect the data and develop the AI model. AI will not work. I have done my PhD in artificial intelligence 20 years back. So I'm a civil engineer, but my PhD is in AI. AI will not work if you are going to develop like any models, like statistical model and all those. It needs massive amount of data to learn the patterns and all those. So that's why, again, you cannot combine like East Vermont data with Atlanta data. You all have to understand the characteristics and all those. You cannot just merge data. And also the data long-term patterns and all those is important to understand that it cannot be one sort of data and then you make the prediction based on that, that this asset is this grade or that grade. So those are important things. So I feel that this is a great benefit. This was mainly aimed for the utilities, but state agencies are involved and they can also get benefit from this to see that how much utilities they have a permit to withdraw 50 million gallon, but if they are losing 20%, 30%, that need to be taken into consideration. And all these models will be free because these are all taxpayer money. This will be a national scale. So that's kind of what I wanted to present is showing that how can innovation, working in collaboration with the utilities, federal agencies, and all those can help improve these grade what ASC is trying to do. And collecting the right data is the key. Thank you. Celine, I will hand over to you now.
Thank you, Sunil. So we do, if I could get all our panelists back on camera, we do have a few questions from the audience, and then we'll see if we get some more coming into the chat. So the first one I'm going to direct to Samir. There was some questions about the Wichita wastewater treatment plant. Did you guys use anything like Envision to do any type of Envision certification for that facility? I know that's a big thing we mentioned around, sustainability and resilience. Was that something that was considered?
Yeah, so we did not explicitly follow the Envision framework, right? Which is, you're hitting certain categories and trying to go by them. But, in looking through the framework, we touched upon pretty much everything during the project. And that's becoming very typical, whether you use the framework or not. Like when you look at risk and resiliency, right? I'll just talk about that for a second. So in case of Wichita and a lot of other jobs, the first thing we look at is floodplain analysis. We look at like where to put the structures. Do we raise some of the tanks just to account for a long term? In a lot of cases, we're seeing the 100-year and 500-year floodplains are changing, right? And so we've got to account for those. So there's a lot of that going on. When you look at you look at social well-being and public health. I mean, one of the big things at Wichita was odor control. I didn't really stress upon that here, but that was a huge thing they wanted to accomplish through this job, looking after the community needs and making sure that the wastewater plant was adapting and being sensitive to what the community needs were. So there's so many things in that project that touched upon all aspects of Envision, but we did not chase like a specific certification or use that framework directly.
Yeah, and it can be pretty lengthy. I've been involved in a few projects for New York City that tried to apply Envision. I mean, it's not like a very simple process.
Yeah, right.
Lita, have you guys done anything around Envision with your utility and any of your wastewater facilities? Is that something that's come up?
We have not, no, but something that we're, with it being a newer tool, we would definitely, look into it potentially and consider it.
Great. Well,
at least to my knowledge, we have not. I should say that.
And it's really not super common, like with really large utilities like New York City DEP. That's the only place that I have run into, trying to do Envision. So, like I said, it can be a pretty big process to use as you're going through the full design and construction. Lita, I have you. There is another question in the chat around how you guys report your SSOs. Do you track them by cause? Have you seen improvements in capacity related SSOs versus force main failures? And is there any type of regional reporting in your area? So lots of questions around SSO reporting.
Yeah. So one thing to be clear, the Northeast Ohio Regional Sewer District does not regulate the member communities with their SSOs. When they do find them, they are supposed to report them to Ohio EPA, but we ask that we are included in the notification so we can, again, find ways to help them address this issue. If it's a lot of times it could be a maintenance issue, and then if it is a capital improvement, again, kind of going back to the results of the studies that we've done and encouraging them to apply for funding resources to address those issues. But the force main question is something of interest, and so to my knowledge, while these items are reported, being able to kind of search for that data to kind of help support report card development, I haven't been able to find it.
And that brings me to another question that I will throw out to all of our panelists, maybe starting with Sunil. And we've heard this question many times, and that's what can be done to make the ASCE report card more data driven. And I would say we had another question in the chat on the wastewater that I just answered, but we were really challenged on wastewater. The EPA needs assessment has not been done since 2022. So we didn't even really have that type of data. So yeah, we would love to have more data. So I don't know, Sunil, if you want to talk a little bit. I know you've had ideas and some projects around data.
Right. Yeah, I mean, so yes, we need to have, I mean, we are not going to get all the data in the world we need because it's not possible. But we can get enough data with the sampling and all those to extrapolate. That will be a good start instead of just kind of making a subjective judgment. So my recommendation to ASC will be to start with whatever data is available and make grading based on that asset by asset, because that's what we are calling it agent here in the modeling business. But if you combine all those assets, then clarity will come, because when we say water infrastructure cumulatively, if we are saying C, but if you carefully look at that, the pipes or hydrants or different assets, they will have different grading, right? Even if it is not perfect, but if we can have some methodology to estimate that and then cumulatively, so then there will be a feedback loop. Because if we are saying C, if a utility, and that question came in this study when we started with this USGS, Sunil, don't come and tell us we are losing 30%. In general, we know we are losing 30%. But from where, which pipe, or from hydrant flushing, or even by the practice, are we flushing hydrant more frequently? So that is more, feedback loop is more important, and that can only be done by collecting some good data from asset by asset.
Yeah, we rely quite a bit on the AWWA benchmarking, that is a sample of utilities. Typically, it tends to be, across the country, but not more, I would say more of the medium to large utilities are the responders. So you really don't get a look at the smaller utilities performance, which a lot of times can be worse than because they don't have the funding from the medium and large.
Right. So I will tell you, based on our study, again, I haven't shown everything, probably we will publish. What we saw is, in average, from water loss point of view, the smaller utility who is pretty much zero asset management, they are losing in the range of 50 to 60% of their water, what they are withdrawing.
Wow.
That's a big number.
It is a big number, but it's small comparatively to the amount of water versus when you think about, what all the large utilities are producing.
Right. Yes. Yeah. Percentage wise, it looks right. You're right. Volume wise, the larger, but larger one also with the leaky pipes, the larger one, I will not name any utility, but bigger utilities, even percentage is low, but volume wise, it's a big loss.
Samir, any ideas from you on how we can, you're kind of on the outside of this, Lita and I have lived through it, of how we can have more data-driven report cards versus how we do it now?
No, I was going to actually take off from what Sunil just said. You're talking about breaking it down by asset, which is a
Right,
great idea. And then also understand the criticality of that asset, which I think
right,
we're all alluding to, right? Like
Mhm.
right.
a single pipe break somewhere could be huge
Yeah,
because you suddenly shut everything down.
right,
But
right,
losing a pump, 1 out of 3 pumps may not
right,
be that impactful, right? And so
right,
I think those need to play into some of the formulas or whatever methodology we develop in the future, right? I mean, that could play,
right,
given the fact that a lot of utilities are generating that kind of data now. As the asset management systems get better and you have a better understanding of what you have in the ground versus above ground and things like that, right? So I think that would be the only other thought I would have on this right now. Yeah.
Which is interesting because some states require asset management plans. My expertise, I've done tons of asset management plans across the country, and certain states mandated it, and they're collecting them, but then they're not. They're collecting them in like a, I don't know, PDF format or something. There's not
Yeah.
any data collection. But you're
uh,
right. It's
uh,
much. I think it's much more powerful to me to see like the risk profile of the assets,
Right.
how many assets are in very high risk, or, for each of the utilities gives you a better picture than just saying what stuff is in bad condition because of redundancy and criticality and those
right.
types of things. But, I don't know if there is a way to instead of getting PDF reports that are stuck somewhere to get something more like a data spreadsheet that has information would be way more helpful. To be able to understand what it looks like across the country from an infrastructure. And didn't Ohio had requirements? Maybe they were just for water asset management plans, but I know Ohio required people writing asset management plans, and then I think they just went into a void somewhere. So I don't know if you had
Yeah.
we worked together on wastewater. Any thoughts there about data?
Yeah, I was just going to say, yeah, it's always hard to find the data. And you mentioned something, the PDFs versus being able to share it. If you actually go onto our website, we actually have the sewer district's website. We actually have a dashboard, kind of showing all the different programs and so I think being able to kind of share information, and then also realize that when we're looking for data, that it's all to kind of support the discussion. It's not kind of showing that utilities are doing a bad job. They're doing a great job with the limited resources that they have, but this tool of the report card is really to kind of help bridge that gap of trying to recognize that need, for funding and additional resources to address problems.
Yeah, and I would say one of the things we have a lot of, I'm sure we've got a bunch of engineers and water and wastewater technical folks on this particular webinar. The report card is meant more for the average person to read, not necessarily for technical folks like us who sort of live it and breathe it. So we try to make some general statements that people can understand. It's really an advocacy type of a document. So that's important to understand too. I've got some questions in the chat, about really specifics about the references in the report cards, in the report card. Some comments about, water loss in the U.S. is more like 4 to 5 trillion gallons per year. The citation on the slide might have been more of a global overall water loss. But yes, data is a challenge, and I think we'll just leave it at that. We rely a lot on the AWWA benchmarking. As I mentioned, the EPA needs assessment, which has not been updated for wastewater, which was a big challenge. We look at any other studies, whether those are AWWA studies or Utah State had done a study on pipelines. So we try to do what we can. We actually also partnered with Bluefield Research, who does research on surveying utilities. But most of our data is around like I would say a survey of utilities. It's not an aggregate of
Yeah.
data from
So,
utilities.
right. So, Celine, I will add on that also when you said survey. The challenge in water industry is when you do survey, there is no right definition. So if you are looking for a break rate, if you talk to 10 utility, they will define break in 10 different ways.
Yeah.
It's very true.
Yeah.
Right. And then based on this survey, now you are coming and making, again, it is orange up. So we have to be a little bit careful. Survey works very well when there is an industry standard is defined, when everyone
Yes.
says what failure mean. This industry cannot define even failure.
Yep. Understood. So let's move on to funding a little bit. I think we've beaten the data thing to death, and thank you all who've put things into the chat. Where's 25 data for this or that? Sometimes it just doesn't exist. We're doing our best to cite the sources the best we can. And in terms of like the AWWA benchmarking, the 25 report doesn't come out until after 25 is over. So you'll see that published in 26. Right now, 24 is the newest one that's out there. But I have a question, and this one is interesting. So the level of investment gap seems daunting. Yes, when you look at the needs out in the next 20 years, it certainly does. So let me start off. I guess we'll start with Samir. Is there any type of support tools that you have seen utilities using to help them invest more strategically and trying to deal with constrained funding and how they make that juggle? Have you had any interaction with that or anything you want to
Yeah.
share with us? And then I'll just
Well,
move to Lita and
yeah,
Sunil.
sure. No, this is a big deal, obviously. I mean, it's always the same, right? It's like, how can I do the most I can with the limited amount of funds I got, right? And so there's two aspects of this. One is where do you get the funding from, and fully understanding like what avenues you have, like these WIFIA programs, SRF programs, things like that. So we see that a lot in our industry. Like, how can we help them find the money that is available? Because sometimes utilities don't know where the source of the money could be, or there could be money there to have. The second thing is this whole concept of CIP planning and how best to plan your investments. So you have like a sort of a money flow assigned and the things you're going to do. And we do that typically as part of our master planning efforts or just facilities planning effort. And we always end that with some kind of a plan for the next 10 years or 20 years of infrastructure investment. Um, and that's where the strategy comes in, right? What's most needed? That's what ties in this whole concept of data, asset management, et cetera. Like, do you fix the low-hanging fruit first? Do you look at big picture things later? Maybe you're getting ready for things like PFAS on the wastewater side 10 years down the road. But right now, maybe you want to put things, if you're improving things, getting ready for something in the future. So that strategy part becomes extremely important as you plan that out.
Yeah, and
Uh,
there's cool new tools. I will just say, not that I'm trying to plug Arcadis, but there's others as well. There's tools now where if you set like your service levels or your priorities, that you can put in different capital plans and you can say
right.
maximize resilience or maximize regulatory compliance,
Exactly.
or I only have a cap of $150 million over 5 years, and show me the best project plan that I can do that's going to hit my goals. And so it'll spit out like a different Gantt chart with projects, depending on how you're trying to optimize. And you can use these tools kind of like in real time when you're doing, your capital planning, and it's super helpful because in your mind you can't think of like 5 different priorities
Exactly.
and weighted criteria. So there are some new cool tools out there.
Yeah,
So
using what we call adaptive CIP, right? I mean, you can
exactly,
adapt
yeah,
to certain criteria and come up with a
yeah.
CIP plan and change it every year or every few months,
Yeah,
depending
or
on if
even
certain
run like
factors
5
change.
scenarios and see
Right,
what the difference
exactly.
is.
So we
So,
do
so
that a
Lita, I
lot.
think we're
Yeah.
going to close up with your thoughts on, the daunting investment gap and maybe how you guys,
Mhm.
if you're using any tools or any particular methods, and that will get us to the end of our webinar.
Sounds good. I think I'll close it with partnerships. We rely on our consultants and our national experts and different agencies to kind of keep us informed of what funding is out there. And one other, kind of talking on the bringing back the local side. What we have at the sewer district are called water advisory committees, and so we're bringing all the stakeholders of those communities in the different watersheds and letting them know biannually what's going on in the service area. So it fosters collaboration and informed planning and to potentially collaborate to find out what additional funding is out there, resources. So that's a great avenue. But other ways in partnerships is sometimes we partner with other agencies to do a project. We had a interceptor sewer that was failing, and another agency was doing a slope a stability failure project. So by combining efforts, rather than having two separate designs and two separate construction, combining it into one made it a little bit more efficient in order to implement. So, that's a really great strategic way to get some of these projects done.
Yeah, I mean, machine learning and AI is great, but it comes down to like you still need to interact with each other and make good decisions. So Josh, I know there was a comment in the chat about how do people get the slides. If you just want to wrap us up and let folks know how to get the slides, I'll let you close us out.
Happy to do so. Thanks, Celine. And yes, so slides will be available in a blog post, which we will make sure to publish next week. And for everyone who's registered, they will get the link to that blog post that will include the slides as well as this recording as well. So with that, appreciate everyone's time and attention today. Again, for those who were able to join us, thanks to our panelists as well, Sunil, Samir, Lita, and Celine, for your time and preparation and contribution to this really great discussion. I want to thank especially our sponsor today, CM Smith, for helping us support this webinar. And for all details related to the 2025 report card for America's infrastructure, please go to infrastructurereportcard.org. Thank you all again. Hope everyone has a nice rest of your day.
Thank you.
Thank you.
Thanks. Bye.
Yep. Thank you.